Good morning, sir. My name is Himanshu, and today I am presenting my machine learning internship project titled Predictive Modeling of Heart Disease using Machine Learning Algorithm. This project was completed during my 6-week internship under the guidance of Mr. Abhishek Bakla, sir, Assistant Professor, Department of Electronics and Computer Science Engineering, NIMT Ranchi. Uh, So basically, first I will explain my project through this presentation, and then after it will be followed by the working demo of my project. So let's start. So the main objective of this project was to develop a machine learning based system that can predict the likelihood of heart disease using clinical patient data and compare different algorithms to identify the most effective model. Now, the clinical challenge was to that we all know that the heart disease is one of the leading causes of death worldwide. WHO has also predicted that approximately 17.9 million deaths annually are from cardiovascular diseases, and 31% of all global deaths are caused by cardiovascular diseases. And also economically, burden is also there as billions in health. It costs billions in healthcare costs annually. And traditional diagnosis depends heavily on physical expertise and available clinical information. However, challenges that as cognitive fatigue, time pressure, and complex patient data can sometimes affect decision making. And the main solution is that we can have a ML powered decision support system which offers an opportunity to assist the healthcare professionals by identifying the hidden patterns in patient data and provide accurate decision support. Therefore, this project focuses on developing an intelligent prediction system for early health disease detection. Now, now the first, then we will see the background and the literature review, which is done before developing this project. As historically, heart disease prediction evolved from statistical models like in the 1990s to machine learning techniques which leads to machines like support vector machines and k nearest neighbors in the early 2000s. Recent studies have shown that in advanced machine learning models can significantly improve prediction accuracy. Researchers such as Ali et al., Khanna et al., Mohan et al. Have developed many models and incorporated key findings and that demonstrated that machine learning can be highly effective in healthcare applications. Inspired by these studies, I aim to compare multiple algorithms, identify the best performing model for this heart prediction system. Now the project objectives and scope. The project consisted of five major objectives. First, collecting and analyzing patient data through exploratory data analysis. Second, pre-processing the latest data set by cleaning, scaling and preparing the data. Third, the training multiple machine learning algorithms. Fourth, evaluating the performance of each algorithms using different metrics. And then finally, deploying the best model through an interactive prediction system. Scope of this project is limited to binary classification, which means that models basically predict whether a patient has heart disease or not. So my model basically predicts we will enter different sets of data which is required by it, and then it will predict that the patient has heart disease or not. It is designed as a decision support tool and not as a replacement or not as a replacement for medical professionals. Now the machine learning algorithms, I evaluated seven algorithms like the logistic regression, naive support vector machines, k nearest neighbors, decision trees, random forest, and XGBoost. whereas which is and the k nearest neighbors have the was selected, it has a best accuracy of 92.5%, and it also handles the non-linear patterns of and handle noisy it also handle the noisy clinical data efficiently. Now we will move to data pre-processing and features. The the Now we will see the data set which is used for training this model. The data set consists of 303 patient records with 40 clinical attributes. These attributes include age, gender, blood pressure, cholesterol level, chest pain type, maximum heart rate, ECG results, and other medical indicators. And the pre-processing pipeline involves data cleaning, data analysis, correlation analysis, feature scaling, standardization, and cross-validation. These are the steps of the pre-processing data. We started with the data cleaning, then ETA, correlation and standardization, and cross-validation. The next, the model training and results. We trained the model, and I stated that KNN was the best model with 92.5% accuracy and precision of 91%, recall of 93%, F1 score of 0.19, AUC, ROC covers 0.965. Which means that the model successfully identifies the most patients who actually have heart disease. When compared to other algorithms like the logistic regression, random forest, XGBoost, KNN consistently produce the best results. Now implementation and interactive CLI system. After selecting the best model, I developed an interactive command line interface prediction system. Then using that developed model, I developed a prediction system which consists of workflow of following 6 steps. First, the loading the trained KNN model. Second, collecting patient information. Third, validating user inputs. Fourth, and applying feature standardization. And fifth, generating prediction using the trained model. And finally, displaying the prediction results along with the confidence information. I will show everything after this presentation. You will able to understand the different attributes which I am for of which I am talking about. Now, in conclusions and the impact, key find and then finally the conclusions and the impact was like the project successfully demonstrated application of machine learning in healthcare. The key achievements include building a complete prediction pipeline, evaluating 7 machine learning algorithms, achieving 92.5% accuracy using KNN, and developing a work prediction system. And the clinical impact of this work lies in early disease detect the disease will be detected early, reduce diagnostic errors. It will reduce the diagnostic error which can be caused, and improve decision making support for healthcare professionals. In the future, this system can be explained into expanded the future out for future work. It can be also enhanced by expanding it into a web application integrated with hospital databases, which means we can integrate with the different hospital databases and enhanced. It can be also enhanced much using deep learning techniques. Now, this was a future work and then algorithm comparison and selection. This slide explains why Kenan was selected as a final model. I have all previously stated that it has the highest accuracy, strong robustness against noise, easily interpretable, inter fast prediction, and scalability of future data. KNN works by finding the nearest similar patient records and making prediction based on those neighbor cases easy. And now we will see the next slide, that is technical implementation. This, this slide explains about the whole workflow, the whole development workflow of my model, and the technology which was involved. It involved Python, Skitlearn, NumPy, Pandas, Matplotlib, and Pickle. This whole libraries were involved in developing the model. And then the development workflow includes exploration, EDA analysis, then pre-processing the data, then training the data, and then followed by evaluation, optimization, which include tuning and analysis, then deployment, and then testing, and then documentation. This was the whole workflow. You, uh, you can also read a data flow diagram or DFD of my work. Now we'll see these are the snapshots of the model implementation. We can see here that we can first a model will be trained, and we have to upload a data set. And based on that data set, 7 different types of models will be trained. And out of that, KNN, you can see KNN has the maximum accuracy, 91.8% accuracy at Kn, which KNN had. Then it will load 2 models, load to file which will be saved. This model will be saved in heart disease model.pkl, which will predict the that which will predict the disease, heart disease. And as another file called scalar.pkl will also be scored, which and which is a pre-processing object that scales patient input before prediction. Now, like the prediction system, we will enter the details one by one in numbers. We can say we will. You can see that 1 for male, 0 for female. Similarly, in the chest pain types, we can see there are different chest pain types numbered as 0, 1, 2, 3. We have to manually enter the details, and then all the 13 types of attributes which will be required by the model to predict the disease will be entered by us, and then we can say the result low risk, no heart disease detected. We can subsequently also predict another patient as the after and after detecting a disease for one patient, the model will automatically ask if we want to predict another patient or not. If we click on yes, then the interface will be on loop. We can answer we can enter details one time more, and then if we enter no, it will display thank you, and the model will be closed. Now we will see the working demo of my model. You can see here, I have developed model in Google Colab. We will start by training the model first. You can say that model is being trained. First, we have to upload the dataset file. We go to choose file, and then we will upload that required file. You can see that this is the dataset, and then based on that, the model will be trained. We can say Canon 91.8% accuracy. It will ask me permission for allowing the files to be downloaded. This file will include this head disease.model.pkl. The whole model is stored in this heart disease model file, and the scalar then pre-processing object will be stored in scalar.pkl. And now we will train that this is the main prediction system file. You can see here this is the main prediction system file, which include all the 13 attributes which will be required for predicting the disease. Now we will train this. First, I will show you both. First, we will enter a patient having a high risk of disease. Now we will enter age. The age will be now. Let enter age will be 34. Then gender, it will be female. Then chest pain type, let it be atypical angina. And then resting BP, let it be 118. And then cholesterol, let it be 182. I am entering hypothetical details. Now the fasting blood sugar is greater than 120 mg. Let it be no, that is 0. Resting ECG, that let it be normal. And then Maximum heart rate, it having 176. Exercise induced angina, that will be no. ST depression exercise, that will be 0.1. Upsloping, CA, that will be 0. And then let it be thyroxine will be normal. We can see there is a high risk of heart disease. Now, if you want to predict another patient, and then I will show you a normal patient, normal person having no heart disease. So we will enter here yes. We want to predict another patient. Now we will enter age. Let age be 63. Then gender will be male. Then transplant type be typical angina. Then the resting BP be 150. Serum cholesterol be 285. Then fasting blood sugar be 1. Resting ECG will be 2. Then get resting ECG, that is left ventricular hypertrophy. And then maximum heart rate achieved will be 110. Then exercise induced angina, that will be yes. Old peak, that will be 3. Then let it be random number 3.2. Then let it be down sloping, and the number of major vessels is 3. Thalassemia by 3. We can see that there is a low risk, no heart is detected. So this is a normal person record. Now we don't want to and want to know of any further patient. Then we will enter here and which means no. Then it will the model, the prediction system is now executed. We can see here it will mention thank you. So sir, after training the model, and I have developed an internship report based on this predicting system, which include this following topics. Start the main topic will start from this main extract, and then build a table of contents. Consider abstract and introduction, which consists of background, a problem statement, project objective, scope of study, then literature review, foundational studies in cardiac prediction, advancements in machine learning classifiers, system implementation, then theoretical framework, which include a seven models which I have trained. I have mentioned all the details about its seven models, then methodology, system architecture, which consists of the project workflow, system architecture, hardware and software environment, then data pre-processing and exploratory data analysis. I have maintained different sections for different steps of why which was involved in developing this prediction system, then model training evaluation, prediction system implementation, conclusion, future work, and also the mentioned references which I have used after reading different research papers, and after an appendix which consists of a general system code overview. We can see here these are a different description of the models, the methodology, then hardware and software involvement, data pre-processing. We can see here the different meaning of all those 13 or 14 attributes which I have entered for predicting heart disease. Then the target class distribution. I have also mentioned different plots and graphs which consist to demonstrate this prediction model. We can see here the most accuracy of KNN model. And I also attached a snapshot of the prediction system. You can see here AC and ROC curve analysis comparing model sensitivity and specify the trade-offs. You can see how the evaluation of precision recall and F1 score is held. So thank you, sir, for giving me this opportunity of learning under our guidance in this internship. Thank you.